So we're going to do question number 1 on chapter 9 on page 191. The question reads, suppose that the input piston of a hydraulic jack has a diameter of 2 centimeters and the load piston has a diameter of 25 centimeters. The jack is going to be used to lift a car of 1,400 kilograms. So that's the mass. So we have question 1. We have hydraulic jack. If you remember, on a hydraulic jack, we have a small piston and a large piston. And they're put together by a path where the fluid in here can access the fluid in here and vice versa. So we'll have an eraser. Let's take off that little line there. And let's take off that one there. Okay, so this is continuous. The fluid can access each other. So what's going to happen is, for any given depth, the pressure here is going to equal the pressure there, because if the pressure builds up here, it's going to feel free to flow to a lower pressure. And that will continue going on until we reach equilibrium. We're told that this piston, the whole thing is the hydraulic jack. This is a piston, this is a piston connecting tube. This piston has a diameter of 2 centimeters, and the author called that the input. And this is the output, or the load. The author called it the load. Since we called this an in, maybe we should call this the out. Just keep in mind that it's okay to call it the load, because you are loading it up with a car. And the diameter there is 25 centimeters. And then we have a car on here. The mass of the car is 1,400 kilograms. So the weight of the car is equal to mass times gravity. So that's going to be equal to 1,400 kilograms times 10. So the weight is equal to 14,000 newtons. See these 3 zeros here? For that case, sometimes this is written as weight is 14 kilonewtons. Right? Meters and kilometers. Kilometer is 1,000 meters. Well, 14 kilonewtons is 14,000 newtons. So these are equivalent. They're the same. Just replacing the 3 zeros with a K. All right, moving right along. We get question A, part A of question 1. What are the areas of the input and output piston? All right, this is a circle, circular. So the area for a circle is equal to pi r squared. So we can use, for the input, the area of the input is then equal to pi times r squared. Well, d, the diameter, is 2 centimeters. That means the radius is 1 centimeter. Still got to square it. So we get AN is equal to 1 squared, centimeter squared, and pi. So that's just equal to pi centimeters squared, right? 1 times pi is still pi, but we have to keep the units. So that's in. Now we have out. Well, again, area is still pi r squared, because this is still a circular top. So the area out, or load, is equal to pi times r squared. Well, d is 25, so r is 12.5 centimeters, and that's squared. So A out is equal to 12.5, that's 156.25, I hope. and we can't forget about the pi, centimeters squared. So that's the area of the out. So that was part A. Now just a couple of words. You may wonder if it's okay to leave this as pi, or do I have to write out 3.14? I will accept either. I'll accept either. What about here? Do you have to multiply 156.25 times pi? Well, you have to get an answer, but this is okay for me, or you can multiply it by pi. Remember, pi is equal to 3.1415, dot, 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 dot. Okay? So that was part A. Part B. What is the ratio of the area of the load piston to the area of the input piston? So part B, what is the ratio of the area of the load or output to the area of the input? And you can use the word load or out. I like out. So the area of the out is given here as 156.25 pi centimeters squared. And the area of the in is just pi centimeters squared. Notice that centimeter squares cancels and the pi cancels. So we wound up with 156.25. Notice there's no units, it's a ratio. The units canceled, which is why, since the units canceled, that's why we did not have to convert to meters. I left it in centimeters. I did not have to convert to meters, because I knew in a problem like this, where we're dealing with a ratio, the units would cancel. Remember, so this is the answer. So that's our ratio. Also notice that the author asked for area of the output, the ratio of the area of the output to the input. That means the output goes first on top. If he asked for area of the input to the area of the output, then it would be opposite. So that's our answer to B. Moving right along to C. What is the weight of the car in newtons? Well, we already did that. Weight is equal to mg. So weight is equal to the mass. Author told us the mass of the car was 1,400 kilograms times gravity. Well, gravity we know is 10, and we also know it's newtons per kilogram. If you remember from our first lab, we used the units of newtons per kilogram. Otherwise, you can use meters per second squared, but then you have a little more work to do to get the units to cancel out right. So this implies the weight is equal to, well, 1,400 times 10 is 14,000. And then notice the kilograms cancel, so we get newtons. So that's our answer. You may see someone say 14 kilonewtons. Remember what the K is. You're multiplying by 1,000. That's where these 3 zeros are. See, I took out those 3 zeros and I put in the K, so these two are equivalent. It's like meters and kilometers. A kilometer is 1,000 meters. Okay, so that's our answer to C. We're moving right along. How about D? Part D, our last part. What force must be applied to the input piston? So you want to lift this heavy car. How much force would you need to lift a heavy car in this particular case? Well, remember what we have. Our formula is for the hydraulic jack and for a piston, pressure is equal to force over area. Since we open this up, we know that for any given depth, the pressure in this piston will equal the pressure in that piston. Because once again, if the pressure builds up here, the water is just going to, well, the fluid is just going to flow over to here until you have equilibrium. So we have the pressure in here equals the pressure in here. But pressure is force over area. So the force over area here equals the force over area there. So our formula becomes force in divided by area in equals force out divided by area out. Remember, this is the in, this is the out. We want to know what Fn is, so plug in. It's going to be one equation, one unknown. We could do a little bit of algebra and say Fn is equal to F out times what? I'll multiply both sides by area in. You already have F out on the bottom, A out on the bottom. Now we plug in. Fn is the unknown, that's what we want to look for. How much force do we got to apply to lift a 14,000 Newton car? So F out is the weight of the car, 14,000 newtons. 14,000 newtons times area in. Well, our area in was pi centimeters squared, and area out is 156.25 pi centimeters squared. Once again, the pi's are going to cancel, centimeters squared are going to cancel, so we wind up getting 14,000. Looks like 89.6. I hope. Newtons. Centimeters canceled, so the only unit I have left is newtons. So to lift this 14,000 Newton car, we only have to apply 89.6 newtons. But what's the catch? We know there's going to be a catch in here, because nothing's free in this world, right? So the question is really, how far do I have to push this piston in to lift this car, let's say 1 meter? That question was not asked on the problem, but it may be asked on the test. So the way to do that is use work, energy conservation. Work in has to equal work out. So force in divided by how far in you have to push this piston. How far in do you have to push this piston to get work out? Work out is force out multiplied by distance out. How far you have to press this one. So force in we have is 89.6. Distance in is our unknown. Again, that's the distance you have to press this piston in. Equals force out, 14,000. Multiplied by distance out. So let's just say 1 meter. Let's keep the numbers easy. If you just wanted to lift this car 1 meter, it's just a little bit more than 36 inches. So 1 meter. What do you get for D in? I'm going to do that one on a calculator. 14,000 divided by 89.6 equals 156.25. That number sounds familiar. Oh, right, that's the ratio, of course. Equals 156.25 meters. So to lift this car 1 meter, you have to push in 156 meters. Is it worth it? Do you have the room? Real world problems. Okay, so that's question number 1.